This video will help you in gaining an understanding of how to determine the number of protons, neutrons, and electrons for a given element. One of the first things that we need to be aware of are some important terms which include atomic number and atomic mass. As we look at the image at the lower left-hand portion of your screen, this represents the element oxygen within the periodic table of elements. The number 8 that you see just under the word oxygen represents the atomic number, whereas the number at the very bottom represents the atomic mass, 15.999. So now that you have an understanding about the subatomic particles, which include protons, neutrons, and electrons, we'll discuss how one should go about determining the number of these components for a given element. To determine the number of protons for a given element, we need to know the atomic number. Just as we can see below, the atomic number for oxygen is 8. As a result, this lets us know that we have 8 protons for this particular element. To determine the number of neutrons for a given element, we need to know two things. One, the atomic mass, and the atomic number. To simplify this, we can create an equation which is N equals M minus N. The N represents neutron, the M representing mass for atomic mass, and the lowercase n represents the atomic number. To determine the number of electrons for a given atom, it truly depends on the situation we're presented with. If the atom or element is neutral, meaning it is existing without being joined to another element, we simply have to identify the atomic number. To identify the number of electrons. Now, if the atom is considered to be an ion, we have to consider the charge. Before we expound upon this, let's revisit what we've looked at so far. For oxygen, we know that we have 8 protons because of the atomic number, which is identifiable on the periodic table of elements. Now, for the number of neutrons, we need to first round the atomic mass to the nearest whole number. For us, that means we're going to round 15.999 to 16. Utilizing our formula of N equals M minus N, we'll see that 16 minus 8 gives us 8, for a total of 8 neutrons. And lastly, to determine the number of electrons, because this atom is occurring by itself, we can simply refer to the atomic number, which is also 8. Now, let's go back for just a second to see what we said about an atom being an ion. Let's say that we have Ca2+, meaning calcium with a 2+ charge. This means specifically that this atom of calcium has given up 2 of its electrons. What we would have to do to determine the number of electrons is look at the atomic number of calcium. If we look at the periodic table of elements, we'll see that the atomic number is 20. Because 2 electrons were lost, we would simply subtract the number of electrons from our atomic number, meaning that there are a total of 18 electrons for this ion. Let's look at another example. Let's say that we have nitrogen with a -3 charge. We again would need to look at the atomic number of nitrogen, which is 7. Because the -3 charge means that 3 electrons were actually added to this molecule, it would mean that we should add 3 to our atomic number, giving us a total of 10 electrons for this ion. As we continue discussing the subatomic particles, we need to become familiar with what is known as the Octet Rule. This rule states that atoms that have fewer than or more than 8 electrons on its outermost energy level will either attempt to lose, gain, or share electrons with other atoms to achieve stability. In other words, having a total of 8 electrons on its outermost shell means that an atom or element is stable. As we'll see here, the charges that we've mentioned are again either protons, neutrons, or electrons. Within the center of a given atom, we'll find the nucleus. Within the nucleus, we'll find the location of both protons and neutrons, noted here by the blue and green circles that you see. The first electron shell can only contain up to 2 electrons. On the subsequent shells, each can hold up to 8 additional electrons. Depending on the resource you utilize, this number may vary, but for our purposes, we'll stick with a total of 8 on each subsequent electron shell or valence. Now, take a moment to see whether or not you can tell which, if any, of the atoms pictured next are stable.